everyone, in today's video, let us learn how to detect different objects using capacitive, inductive and photoelectric proximity sensors. Objectives. At the end of this video, you will be able to detect different objects using inductive proximity sensors, detect different objects using capacitive proximity sensors, detect different objects using photoelectric proximity sensors. Let us collect the tools and equipment required to do this practical. Trainees Toolkit 1 set. Soldering iron 25 watts by 240 volt 1 set. Digital multimeter probes 1 number. Battery 12 volt 7.5 Ah 1 number. Inductive proximity sensor 12 volt DC 2 wire normally closed 1 number. Capacitive proximity sensor M18 NPN normally open NC 1 number. Photoelectric proximity sensors 5 VDC infrared 1 number. DC bulb 12 volt 5 watt 1 number. Connecting wires as required. Let us discuss inductive proximity sensors. An inductive proximity sensor is a type of sensor used in industrial automation to detect the presence or absence of metallic objects without physical contact. Inductive proximity sensors operate based on the principle of electromagnetic induction. They generate an electromagnetic field around their sensing face. When a metallic object enters this field, it disturbs the field, causing a change in the sensor's output. When a metallic object approaches the sensor's sensing face, it induces eddy currents within the object due to the changing magnetic field. Task 1. Detect different objects using inductive proximity sensors. Step 1. Identifying an inductive proximity sensor from its specifications involves understanding the key parameters typically provided in the datasheet. This indicates the maximum distance at which the sensor can detect the presence of a metallic object. It's usually given in millimeters or inches. Step 2. Two-wire inductive proximity sensors typically have only two terminals, one for the power supply and one for the output or load. Step 3. From the specifications, identify the positive and negative terminals of the sensor and the input supply voltage rating. Step 4. Connect the positive terminal of the battery to the positive terminal of the sensor through the load in series, like an alarm, lamp, buzzer, etc. with the correct polarity. Step 5. Connect the negative terminal of the battery to the negative terminal of the sensor. Step 6. Once the sensor is connected to the power supply and load, bring a metallic object within the sensor's detection range. Step 7. When the object enters the sensing range, the sensor detects it and completes the circuit, allowing current to flow through the load. Step 8. The load activates, signaling the detection of the object. The load can then perform the desired action, such as switching on a light or sounding an alarm. Step 9. Test its operation by introducing various metallic objects within its detection range. The detection range and sensitivity of inductive proximity sensors are optimized for detecting metallic objects, and they typically do not respond to non-metallic objects such as plastic, wood, or liquids. Let us discuss capacitive proximity sensors. A capacitive proximity sensor is a type of sensor used to detect the presence or absence of objects, including both metallic and non-metallic objects, without physical contact. Capacitive transducers find applications in various fields. Due to their ability to measure changes in capacitance, which can be influenced by a range of physical variables like pressure sensing, level sensing, humidity sensing, force and strain measurement and fluid flow measurement. Capacitive proximity sensors operate based on changes in capacitance. Capacitance is the ability of a system to store electrical charge. When an object enters the sensing field of the sensor, it alters the capacitance of the sensor, triggering a detection signal. When an object enters the sensing field of the sensor, it alters the capacitance of the sensor, triggering a detection signal. The sensor contains an oscillator circuit that generates an electric field around the sensing area. When an object enters the sensing field, it changes the capacitance of the sensor by either increasing or decreasing it. The sensor detects these changes in capacitance and converts them into an electrical signal. The signal is then processed by the sensor's electronics to determine the presence or absence of the object. Task 1. Detect different objects using capacitive proximity sensors. Step 1. Identify whether the sensor is of the NPN or PNP type based on its specifications. For an NPN sensor, connect one side of the load to the sensor's output terminal and connect the other side to the positive supply voltage. For a PNP sensor, connect one side of the load to the sensor's output terminal and connect the other side to the negative supply voltage. Normally open NO. In a normally open capacitive proximity sensor, the output circuit remains open, non-conductive, when no object is detected within its sensing range. Normally closed NC. Conversely, in a normally closed capacitive proximity sensor, the output circuit is closed, conductive, when no object is detected within its sensing range. Step 2. Determine the voltage and polarity required by the sensor from its datasheet. Capacitive proximity sensors usually operate on DC voltage. Connect the capacitive proximity sensor to a DC power supply or battery and load with the correct polarity. Step 3. Once the sensor is connected to the power supply and load, if applicable, power on the system. Step 4. Bring an object within the sensing range of the capacitive sensor. This object should have a dielectric constant sufficient to trigger the sensor, example, plastic plus. Bring it very closer to the proximity sensor input and observe the display for any change. Step 5. As the object enters the sensing range, the sensor should detect it and activate its output, if applicable. Step 6. Monitor the output signal or the behavior of the connected load to verify that the sensor is operating correctly. Step 7. Test with various objects to verify the sensor's reliability and adjust settings if necessary. Recap. In this video, we have discussed how to detect different objects using inductive proximity sensors. Detect different objects using capacitive proximity sensors. Thank you for watching.